Alright, so welcome to the test review for your test number 12. Since so many of you apparently were upset, especially when you were absent, and apparently were looking for this, for the test review number 11, I decided, well, I guess I should be generous and give you another test review for 12. Isn't that so great of me? I know it. Anyways, let's get to number 12, shall we? Alright, so we've got this. I'm starting off with word problems and stuff like that. Those application problems. An object is launched at 19.6 meters per second from a platform 58.8 meters above the ground. So then the question then becomes, first off, take note, here's this and this. So we're using meters. So write an equation which models the situation. Now, if you have this on your note card, which you should, the one for meters is h of t is equal to negative 4.9 t squared plus VOT plus HOT. Now, wait, sorry, just HO. Why did I put T? Oh, goodness gracious. Anyways, so the idea again, we're putting these numbers, you're putting numbers into VO and HO. And we're using the negative 4.9 because we're talking about meters. Basically, the only difference between this one and the other one is that the other one says negative 16 based on the idea that if it's in feet. Okay, so write an equation which models the situation. Did I do that on the next one? I'm kind of curious. No, I gave it to you. Okay, anyways. H of t is equal to negative 4.9. So that's automatically going to be there. That's kind of from where you kind of chose it from. So make sure you have these on note cards and have note cards. These are not things that are easy to have memorized. At least for y'all. Anyways, 19.6 meters per second. So again, it's launched at 19.6 meters per second. I should really come up with one that should have you not doing that. Plus, it's 50.8 meters above the ground. So 58.8 meters above the ground. There's your situation. Okay, so again, how would I go about finding the vertex? Well, the very first thing I would do is I would go to my calculator and graph this. I probably should have been able to take a picture. But I'll go ahead and tell you what I do. Okay, so basically what I did was I pressed home, pressed the on button, and I pressed new document. And I opened up a graphs page. And I typed in this function, but I put the x's in place of the t squares. So from there, I would do a menu 5-1, and I would start going sideways. Okay, so try to take a picture of that. Just 1 second. Okay, so I took a picture of the maximum when I found it, and you can see here it's 278.4. So again, when it says maximum, that's your vertex, and then what is the maximum height of this object? Obviously, this would be the height, and then the other thing would be the time. So it was 78.4 meters high, reached the maximum, and was 2 seconds when it reached that. So how do I find the zero, or find it when it hits the ground? Find the zero. And then again, just go sideways and do a trace. And when you do that, you'll get this. And as you can see here, when it says 0, that's what I'm looking at. So this is when it tells me it hits the ground, and it took 6 seconds to hit the ground. Alright, so that's pretty much it right there. So you can kind of go with that. So now let's look at number 2, or the next set of problems. Okay, 5 through 7. Diver standing on a platform, his dive can be emulated by the function negative. What's the vertex of the situation? Obviously, the vertex of the situation is the opposite of this, so 0.25, comma, 32. How long does it take for the diver to reach his maximum height? It takes him that 0.25 seconds. In other words, he gets there really quick. What's the maximum height the diver reaches? Now, this one, the negative 16 would tell you this is going to be in feet, so this is 32 feet. Okay, if I had put a negative 4.9, then I would have been talking about meters. So kind of keep that in mind. I mean, that doesn't really change for those two. So there you go with that. That pretty much covers that part right there. And I mean, that one you don't even need a calculator. It's really easy to get to. Here's another one where you don't need the calculator. And I did make a oops here, and this should have been from 8 through 11. I will have it fixed on the copy that you're getting. I'm just kind of silly that way, or that you got. I guess I should say it like that. All right. So here's, I see this. It goes, okay, 0, 16, 21, 24, 25, 24, 21, 20. Okay, so I see they're starting to repeat. So then I have to say the vertex is the one in the middle. So what's the vertex of the situation? 2.5, comma, 25. And what's the maximum height? Obviously this one would be 25. I guess I probably would have to squeeze in their feet. But if you just told me 25 or 25 meters, I would probably take it. Okay, then, do I have number 10 on here? No, I got to put it over here. Okay, so then number 10 says, how long does it take to reach this height? So your answer for number 10 is this 2.5. That would have to be in seconds. So number 10 is the 2.5 seconds. And then question number 11 asks, when does it hit the ground? Well, think about this. It goes from here to here. This is when it starts at 0. So that's got to go the equal amount this way. So if it took 2.5 to go over that way, from 0 to the middle, then it would have to go 2.5 again this way. So even though I didn't put it, your answer for number 11 is, what's 2.5 and 2.5? 5 seconds. So kind of keep that in mind, that the thing is in the middle, so I can ask a question where you may not necessarily see the answer on the table, but you should still be able to get the answer. Okay? All right, so a punter, let's look at these two. Punter is trying to win a bet. When he visits the Dallas Cowboys Stadium, he's trying to hit the jumbotron above the field. He kicks the ball with initial velocity of 32 feet per second at a height 6 feet above the ground. The jumbotron is 90 feet above the field. How many chances does the ball have to hit the screen? Now, I kind of put this in a way that, okay, if the jumbotron is here, let's say like that, and the ball goes up, okay, let's say it misses going up, but on the way back down, it somehow has a chance. Like, okay, so you kind of see that that's possible if it reaches that. So what you would have to do is graph this, and you have to realize this is your VO, this is your HO, and we're talking about feet per second, so we're going to use this formula, negative 16 t squared, x squared obviously, plus 32 feet per second, so 32t plus 6. Let's see what we get. Honestly, I don't know. Let's find out. Okay, so this is what I get for making, say, I guess numbers off the top of my head, because this is what happened. And I'll take a picture to show you. So right here, I've got this, and this is the maximum height, and it only gets up to 22 feet. So did he hit the jumbotron? He didn't even come close, and this is probably not a guy that's got a very long career in the NFL. So how many chances does he have to hit the ball based on these numbers? 0 chances. Because the max that his height got was 22 feet, and he's trying to hit something that's 90 feet high. I'm going to say he whiffed. We'll go with that. All right, let's look at the 13. Cameras are set up 30 feet above the field. If a baseball hits a baseball with initial velocity of 28 feet per second. Oh my gosh, I hope this one goes out better. At a height 3 feet above the ground, how many chances will the cameras have to take a picture of the ball at 30 feet? I have a funny feeling I'm going to have to research some numbers that will make this a little bit more realistic. But let's find out. Okay, so on this one, and I don't have really room to take a picture here, I get that it came out to 15.3 feet. That's the maximum height. So if the cameras are set up at 30 feet, that means he has 0 chances of hitting, or the cameras have 0 chances of hitting, or taking a picture here. So guys, just keep in mind, I might keep something very similar, and I'll come up with some numbers that might work better. And I'm just laughing that apparently making up numbers off the top of my head didn't quite work. Oh well. Alright, so now let's get to these. What is the vertex of the inequality? Okay, so on this time, remember, this is standard form, and we're going to say type these into the calculator. So we, again, control doc, you can add a page and you can just keep adding questions. Now, I'm telling y'all, just do the graph. You can try the inequality and maybe you'll be able to find the vertex, maybe you won't. Sometimes it works, sometimes it doesn't. So once you type it in, press menu 5-1, get the vertex. Again, when the calculator tells you minimum or maximum, that's the vertex. So the vertex of this inequality is 2, 2. So 2, 2 is right there. So I'm going to graph this. Okay. Then I use my quadratic slope 1, 3, 5. There's a 1 in front of that, so that's going to stay the same. So that tells me I'm going to go up 1 over 1, up 3, 1, 2, 3 over 1, and I don't have any room to put in the 5, so that's all I got. It's a solid line, and it's shaded below. So below, well, this one's below, this one's not below, so I would shade. Okay, now, number 16 does ask, and I didn't want to take a separate picture for this, give me the 4 other points. So I can see here, let's go back for a second. When I graph these points, that was at 1, 3, and then I have a symmetrical point at 3, 3. Notice how they're at the same height. They're across from each other. Then when I went up 3, I went up to 0, 6, and then I went to 4, 6. Again, notice how they're like 1 away from the vertex, 1 up, 2 up, that type of thing. And there you go. And then you could add in, again, the shading. Oh, I'll do it this time. Whoa. And if you're wondering if that can be fun, yes it can. Okay, and then problem number 17, I'll put 17 over here. Problem 17 asks, are the points 1, negative 3, and 2, 5 solutions? Okay, well, 1, negative 3 falls right over here. Wait, that's the wrong number. Let's try that again. 1, negative 3 is right here. Is that in the shaded solution area? Yes, it is. So your answer is yes. Is 2, 5? 2, 5 is right here. Is that in solution area? No, it's not in the shaded area, so the answer is no. So those questions should be fairly easy if you graph correctly. And that's kind of how those questions go. So let's look at the next set of questions. What's the vertex of this inequality? Now this one you may not necessarily need the calculator, because you remember, you look at these numbers, this is in vertex form. So I can go negative 4, comma 6. So negative 4, comma 6 is right here. Then I take the 1, 3, 5, multiply by negative, so I got negative 1, negative 3, and negative 5, and I'm going to go, that means I'm going to go down. So I can go down 1, I can go down 3, 1, 2, 3, and over 1, and then I can go down 5, 1, 2, 3, 4, 5 over 1. Bada bing, bada boom, make the derive. Oh, this is broken lines. So dot 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 dot, and you get the idea. Okay, so now this is less than. Is this point less than, or is this point less than? Well, this point is less than, so I want to shade in here. So give me 4 other points that were on this graph. Well, again, as you were graphing them, you probably could have been right answering this question, but I'll put them over here. Okay, so I have, after the negative 4, 6, I went down 1, so I was at negative 3, comma 5, and negative 5, comma 5. Then I went down 3 more, so that put me at 2, and I'm at negative 2, 2, and then I would be at negative 6, 2. And that's good enough. That's 4 points. Okay, so are the following points in the solution area? Negative 5, negative 2, negative 5, negative 2 is over here. Yes, it is. 5, comma 2, 5, comma 2 is over here. And that would be no, it's not. Okay, so you can see here these are fairly easy to say set up and graph, at least in my opinion. Here another one, the vertex, negative 3, comma negative 4. So negative 3, comma negative 4. You know, and then here, this number, okay, so the 1, 3, 5 are multiplied by 2 to give me 2, 6, and 10. So now I'm going up 2 over 1, up 6, 1, 2, 3, 4, 5, 6 over 1. Okay, okay, and then give me the 4 other points. Well, let's do the points now. Let's do the points before I finish out the graph. So I've got negative 4, comma negative 2. Negative 2, comma negative 2. I've got negative 5, comma 4. And then I've got negative 1, comma 4. So you can kind of see how I came up with those. This one is a solid one because there's a line underneath. And then this is shaded above. Okay, and so is this above or is this above? Obviously this point appears above, so I'm going to say this is my above. And there we go. Are the following points in the solution area? 1, negative 3. So positive 1, negative 3 obviously is not. 2, 5. Why did I keep 2, 5? Oh, I think I was going to change those points. Oh, well. 2, 5. And how about I graph 2, 5? 2, comma 5 is right here. And that also is a no. So you can kind of see here, I don't necessarily have to say both of them are yes or whatever, but you know, maybe I do, maybe I don't. Just as a reminder, don't forget those are broken when they're shaped like that with no line underneath. Dot, 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 dot. When there's a line underneath, you've got solid. So you can have or zhu. Okay. And again, shade below when it's a less than symbol, and shade above. All right. Now, for those of you that are listening, I tell you what, I'm going to say, I'm going to write, let's do this. So here is your bonus word that you need to write above your name for the test. Bonus word will be, I already think I've done this, but let's go with, what's a good word for the bonus word? Okay, so I am going to say, I'm going to write this word, but I want you to have listened, and I want you to actually write the word. What do I actually want you to write? I want you to write the word bonus over your name, and then that will get you your bonus points. I'm giving, see who pays attention to this. If you do have any questions, feel free to send them to me on Google Classroom, and I will try to answer them as quickly as I can. So just kind of keep that in mind, and I'll do that. All right. I hope this was very helpful. Be ready for the test, and if you have any questions, either ask me before class or ask me on Google Classroom. Thank you very much.